Hello. So today we are going to do the second lesson on fractions. As we covered in yesterday's lesson, we will have a few lessons on fractions, which is the first section that we're going to learn. And so before we get started on today's contents, let's do some work from yesterday. So first of all, what is that number called fractional wise? If you remember from last time's lesson, you will remember that's called a numerator. Hold on. And what is that one called then? It's called a denominator. As I told you before, the best way to remember this, well, it was for me, is remember denominator downstairs, numerator is obviously upstairs, as downstairs is taken. Now, bonus question. Let me just draw a star. What is the line in the middle called? It's called the vinculum. So it basically means divide. And for the vinculum, as to how you use it and stuff, you probably won't need it right now, so its name is all you really have to know. Oh, wait, hold on. Oh, no. Yes. Okay, so now this part is done. And the next part, our old friend Johnny, right? To what? So, see old version of Johnny. Actually, yeah, draw a walking stick. Wheels on the bottom. Yeah, that's my best drawing. So he likes to eat pies. And then so he felt like it. And then he decided to eat this part of the pie. So there used to be 4 parts. He ate 1 part. Now, the first question. The first question. Hold on. First question. How much was left over? And second question. How much did Johnny eat? From last week's knowledge, we know that Johnny ate that, first of all, first question, right? What's left over? We know that that part, those two, and that one's left over. However, not that one. So, remember how to write. Remember how to write a fraction. How much there are total. In this case, it's a stationary 4. How much was left over, which means there used to be 4, right? Oh god, hold on. He ate 1. So does that equal? Oh. How much does that equal? 3. So that's how much was left over. As one was eaten, one part got taken away. Now, second question. How much does Johnny eat? Well, this one will probably be easier, but I'll just wait for you guys to figure out first. So, obviously, as we can see, there's 3/4 left over, which means one piece was eaten, as it is 1 away from being a whole pie, which means Johnny ate that one piece, and in this case, in fraction form, it will be 1/4. Okay, now that we got that out of the way, now onto today's part. What we are learning today, so basically simplifying fractions. What is simplifying? What is basically simplifying fractions? So what is simplifying? Examples. Which is, I'll make a few more examples. Why it is useful and in fact necessary. And at the end, we will have a short simplifying quiz. Okay, let's get started. So, what is simplifying? Well, 4/6, right? Let's just say you had the pizza last night. It has 6 pieces. Your family ate 2, which is not that much to be honest. But there it is. There's 4 pieces out of the total 6 left over. 4 pieces, well, which is, and if you want to figure out like how much you have left over, instead of saying, oh, I have 4 pieces of the 6 left over, you can instead simply say, I have 2 pieces of 2. I have 2 pieces of 3 pizza into of the total pizza into 3 parts. Each part should be 2. What that means is that instead of 4/6, you can simplify that into 2, 3. Now, obviously, you might think, oh god, that's like out of the rules, right? Well, not necessarily. If you never knew this before, then on the fraction, it's like let's just say there's two people's backyards. our good old Johnny. Old Johnny, yes. Ooh, he's got some long arms. And young Johnny. He doesn't need sticks. Now, they're neighbors. At the start, the backyards show, I say, both have a black circle and a red circle. Both of them. Yes. However, one day old Johnny might be like, oh, I want more, so he might have a blue circle. Now, our friend Johnny here, he's jealous. You can't, it's a rule. Two sides, you can't have it unequal. You must always have it equal. And Johnny wants it to be equal, so he buys another one. And now of the same size blue circle. Now Johnny may buy a small blue circle. He might buy another blue circle the same size, and then they might buy, let's just say, a blue rectangle. Johnny might buy a blue rectangle. All in all, they are always the same. As long as you add the same thing onto both sides. So, okay, hold on. So how can we apply this common fact to our question? Well, hold on, let me check. 4, 6. Four over 6. Yeah, this is slightly unrec. Okay, yeah, this is a horrible drawing. Excuse me for that. 4 or 6. It became later as 2 or 3, right? Hold on, let me see if that's a better way to do this. Hold on, yeah, add Siki. Ooh, that might be a little bit too big. Two. 2 or 3, right? Now, according to our scenario, for the pizza case, let me just do that. Hold on a second, this is the worst drawing ever. Yes. So we have 6 pieces, right? And since we have 6 pieces, right? We can literally say that we can think of it this way. The 6 pieces can be easily turned into three pieces, each containing 2 of them. As we can see here, one of these places got removed. Yeah. Hold on, I can do better. Yes. So what we have left is two of the 2 pieces, and if we turn them back into the 6 pieces we have, like that, we realize they are the same, 2/3 and 4/6. In fact, they always are. Now, did you notice any pattern while I was talking about it? If you refer to this place, you can see that this example has already been made. Remember how I talked about you can do the same thing on both sides? As long as you do the same thing to both sides, they remain equal, which means you can do it. Well, exactly here. Let's just imagine the 4 and the 6 are two sides, and each side got it divided by 2, which means they all got the same thing, and it's still equal, and all in all it turned into a 2/3. Now, let's see if we can apply this to our second example, our 10-piece pizza. I'll let you guys work it out while I draw the diagram. For the sake of easy doing, I will just make it 6/12. There's 12 pieces in here, right? If you worked it out, be patient, please. And the 6 of the imagine. So there's 6/12. There's 12 pieces in the pizza. 6 remains, which means the other 6 must have been eaten already. Do you see where I'm coming from? Now, what we can see here exactly is that 6 pieces remain out of the original 12. But from the diagram, we can easily see that half of the pizza has been eaten, consumed. So, how can we explain this mathematically? So, let's just say this pizza was divided into 2 parts. Now we know that from what we've seen that one of these 2 pieces of 6. Now we know from what we've seen that 2 times 6 equals 12, and that means each of these contains 6. So that means in this scenario, in this case, I will be consuming one of these half, leaving one half left over. And do you know what that means? That there's a total of 2, right? However, one has been consumed. That's 1/12. Now, if you go back here, you will realize that 6/12 equals 1 over 2. How do you do that? Now, 6 over 12. Have you realized if you divide the top and the bottom by 6, you can get 1 over 2. This means this is exactly the same as the 4, 6. You can divide both sides by the same thing. However, in this case, I would like to ask you, is there another simpler form that we can take instead of 6/12 and 2 over and 1 over 2? Remember, you can do the same thing to both sides. In this case, there's 2. So first of all would be if you divided the top and the bottom together. Remember, both sides you can do the same thing. You have to do the same thing to both sides in order to make sure the value stays the same. If you divide the top and the bottom by 3, it will become 2/3. No, 2/4. And similarly, if you divide top and bottom by 2, you can get 3/6. Both of these, if you divide both sides of that by 3 again and that by 2, you realize you still come to the same answer, 1 over 2. Still come to the same answer, 1 over 2. Right? So all in all, the main case I'm trying to make is, but if you do the same thing to both sides, the value is the same. For example, 1 plus 2 equals 3, right? And then you take away a 2 on the 2. So let's just say there's 2 3s, right? You take a 2 away from one of the 3s, you get 1. However, the other 3's jealous for no reason. So he also takes a 2 away from himself. Now they're still 1. They're still equal. Now the next step, why wouldn't we leave it in a form like 3 over 6 or 2 over 4? Now, because, as you know, we humans, even if you don't want to admit it, we want more simpler stuff. That's why you see we got computers and calculators to do our working out, right? 3 times 3 equals 5, 3 times 3 equals 9, for example. Instead of working that out in your head, which I'm sure you all can do, you get a calculator to help us. We want simplicity. And 2 over 4 is not in its simplest form. So, however, another reason we actually want it to be simpler, and this is going on to why it is useful, is 1, we like things to be simple, and 2, often when you're talking about fractions, you're learning it at school. If your fractions after you answer a question isn't in its simplest form, then you can lose a few marks due to it. Now, because let me see how we're going with time. I think it's alright. Now, I'm going to do some extension. So, you are used to 4 over 6 and 6 over 12 and these things which I make which I made a lot of example with. How about things like 3 over 3? What do you do with them? At first you may be like, what? Well, this is actually extremely simple. Because remember, from our lesson, this line, a vinculum, basically means divide. Now, this means that 3 over 3 in this case will basically be equal to 3 divided by 3. And it equals to 1. Which, however, in this case, you also have to tell your teachers that it is a 1, or you tell anyone that 3 over 3 is 1, as it is its simplest form. If you don't do this in tests, you might also lose some marks. Now, similar to this, we might meet something like a 6 over 3. No, actually a 6 over 2, to change things up a little. Remember, this sign always mean divide. Divide. This is what you used to looking like, but sometimes you are going to meet this type vinculum. So basically you get 6 divided by 2 equals 3. In these scenarios, just like the last one, you still have to simplify. And this is extremely important. And when we get into basic operations of fractions, you will see why. Now, quiz time. Yay. Okay. First question. Why should we simplify? If you think that you know the answer, I will check with you now. This is because of 2 reasons. It makes things simpler and easier to do, so that when you do more math with that fraction, you get a faster result. Also, in schools and things, during tests, you will require this. They will ask for the simplest form, even if the question doesn't ask for the simplest form. Still write it nevertheless. Now, second question. Let me do a big I. 100 over 150. Ooh. Can you simplify this to its most basic form? It is, if for those who may see it in one step, you realize both sides can be divided by the highest common factor, which you will learn later, of 50. And then that will equal to 2 over 3. Yes. However, sometimes if the number is like extraordinarily big, you don't have to divide by its highest common factor one step and finish it, as you might not find that number for a very long time. Instead, for the questions like this, I think you should hope to simplify it with two or more steps. So, what I recommend you to do is 100 and 150. These numbers that have a 0 in the end always mean that it can be divided by 10. If you can work it out, you realize that will be 10 times 10. That will be 15 times 10. Now, if this thing was 1000, that one's also 1000. You will know that both things are divided by 100. One more, 1000. And even if there's only one in the numerator, you can still divide. You will need to go by the thing in the denominator. You still need to go by the thing in the denominator. So, in this case, you still divide everything by 1000. And it goes on. So, an easy way to do questions like this will be literally to cross the zero out, as you basically saying that you're dividing the top and the bottom by the same multiple of 10. So this gives you 10 over 15. And your next step, you realize both top and bottom can be divided by 5. And then you divide it, and then you get the same results. Just a little bit slower and simplicate in easier cases, but in harder cases, trust me, this will save you a lot of time. Also, in harder and larger cases with larger numbers, perhaps you should find the easiest division rules, which I will explain on my course 2 once we finish our fraction session. Once we finish our fraction section for this period of time. And let's have another question, shall we? Remember, usually when you go to these math classes, I recommend you, if you learn something new, take some notes. 53 over 47. No, hold on a second. 71. Now, I will ask you to simplify this for me. After some trial and error, you'll realize you can't simplify these. Both of them are what you call a prime number, which means they can't be divided by anything. And this I will explore also on my course 2. And what does that mean? How do you simplify these questions? Well, you simply can't. It's impossible. If it was one, have you just leave it like that. This is its simplest form, despite how it doesn't look like its simplest form. Let's just take 2 over 3 again, for example. Have you realized 2 over 3 can't be divided by anything else to give a whole number? If you divide 2 by 3, just say you get 0.66666. If you divide 3 by 2, you get 1.5. You don't get a whole number. And that means that all in all, we can also get another summary from this question. Every fraction in its simplest form have at least one numerator or denominator prime. In this case, sometimes it's both primes. Sometimes it might be 53 over 70. You still can't do anything, despite the fact that you can divide 70 by 1, 2, by 2, 5, and all those things. Okay. So I think our lesson can finish now. Let me do some basic sum up. So simplifying is to make it simpler, which means you divide both the top and the bottom with the same number in order to make sure it's equal. However, I didn't explain this before. You cannot add or subtract the same number. Why it's useful, makes things simpler, and ultimately, you will realize that in a fraction, the numerator or the denominator must be a prime number in order for it to be the simplest form. Okay, that's it for today. Thank you for watching. Please subscribe for my next video for my next video of this course. And if you enjoyed, please like, and I will post ads. For now, homework isn't really necessary, but soon later we will begin to have homework, which will be in the link to Google Docs in the description below. And also, if you have any questions, post at the comment section and I will answer them. However, don't make sure you post it too late because I might not check if it's like a month later. Thank you very much and see you next time.